अस्सलाम वालेकुम। हाउ आर यू? आई होप आप सब ठीक होंगे। टुडे वी विल डिस्कस द डिफरेंट methods involved in developing the corrosion free or anti-corrosion material. We have different methods that we discussed in the previous slides or in the previous lecture, but now we have a different methods than galvanizing, sacrificial corrosion, etc. We have, first of all, in front of our screen we have thermal spraying. So as shown by the name thermal spraying, what is thermal? Thermal mean heat, or therm mean heat. It's mean the spraying of something involving the heat. In this process we spray something that is coating on the particular material for the purpose of protecting it from corrosion or rusting. Before going to discuss this method, we have to look on the two terminologies: what is corrosion and what is rusting. The distortion or deterioration of any metal is called corrosion. But if we specifically talk about the iron, then this is called rusting. It's mean if iron metal is in contact with the air and moisture, so iron metal loses its appearance, or there is a formation of some brown coloring on the surface of iron. This is called rusting. If the same thing happens for any other metal, maybe aluminium, chromium, or any other metal, for this we use the term corrosion, not rusting. Rusting is specific for its mean rusting is specific for iron, while corrosion can be used for any metal. Okay, here we have thermal spraying. It's mean we sprayed something by heating so that it can easily attach to the target material and perform its function as a anti-corrosion agent or anti-corrosion coating. Okay, so first of all, here we involve the melting or heating of material. The material that is coated on the surface of the other material, first of all, involve the melting by the heating, and then accelerated. After the acceleration, why it is accelerated? It is accelerated so that it can collide with the target more effectively. After the acceleration, it collided with the desired target or the subject under observation, and after that it bind mechanically to the target. I repeat it again. I repeat it again. First of all, we select the material on which we have to done the coating by thermal spraying. First of all, we melt the material that is going to be coated on the target, and then we accelerate this material so that it collide with the target and mechanically bind on the surface of the subject or the target. Okay, then how we perform all this? Wire or a powder feedstock. Wire or a powder feedstock metal, maybe metal or a ceramic material. May we can done the coating of metal on the surface of the material, or the ceramic coating is done by the help of thermal spraying. These metal or ceramic material are melted by injecting into the flame. Okay, we select the metal or ceramic depending upon the application. Okay, and then we melt it by the flame, and after the melting, it accelerated and collided and bind mechanically to the surface of the target object. This is the very simple and the very easy way of coating the surface of any material to prevent it from corrosion. We have a different application. The first of all application is, before going to the application, we will discuss the basic thermal spraying. Corrosion is a major problem for the industries. There are four commonly used processes in the thermal spraying. Thermal spraying is the general category in which we have the subclasses or the subdivisions: the flame spray, arc spray, plasma spray, and high velocity oxygen fuel. But only two of these, that is flame spray and arc spray, are normally used for a finishing coating or a protective coating. We have the four different categories for the thermal spraying, but we preferred the two, that is the flame spray and arc spray are normally preferred. All methods of thermal spraying involve the projection of small molten particle onto the prepared surface where they adhere and form a continuous coating. The same thing is here as in the previous slide. First of all, we have to melt the material. Then, after the melting, the molten particle are prepared so that it can adhere to the surface. To create a molten particle, a heat source, a spray material, and atomization project can be done. Upon contact, the particle flattened onto the surface, freeze, and mechanically bonded. First onto the rough substrate and then onto each other as the coating thickness is increased. Yes, because the first contact between the molten material and the target material. Molten material that is going to be coated on the surface of the target material. In this case, the molten material particle phase are in come in contact with the rough surface of the coating material on which coating is going to be done. While after that, we can say that if we can say in other words, first spray of molten material or molten particle come in contact with the more rough surface, while the second spray, or in which you can say that the second round of spray particle of molten particle spray come in contact with its own particle that is already present on the rough surface of the target, so that it can increase the thickness of the coating material so that it can prevent the subject or target for a long period of time more effectively. Okay, as the heat energy, this is the most important and the most you can say that the most important and the highest qualified or highest attribute of the thermal spraying, that is the heat. What is the basic concept of heat in this thermal spraying is that as the heat energy in the molten particle is small, this is very important, I am repeating it again, as the heat energy in the molten particles is small relative to the size of the sprayed component. Yes, the molten particle size is small relative to the sprayed component. The, the process imparts very little heat very little heat to the substrate. It's mean the substrate, the target under consideration or on which the coating is going to be done, is heated very little. Mean there is a very little increase in the temperature of the subject. So as the temperature increase of the coating material is minimum, heat distortion is not normally experienced. This is the major advantage over hot dipped galvanizing. In galvanizing, there is an increase of temperature surface of the target material. But here in the thermal spraying, even this is a thermal spraying, this involve heating, but even then this is the more convenient and more reliable than the galvanizing. Why? Because it cannot increase the temperature of the body. Okay. If we talk about the application, here we have the application. Engineers sometimes specify this process when added friction is a desirable property. Where we have to add some friction, we use this technique, or we can say that when we have to construct or when we have to develop the high temperature bearing material, we done this coating so that we can get the material which has high temperature bearing capacity. Okay, so next we move toward the wire flame test. As the name of flame suggests, that the flame mean fire, mean here we have again melting. First of all, we have to select the wire, and the selecting of wire depends upon the way of its application. Mostly the standard range for the preference of wire is 1.6 millimeter to 4.76 millimeter. The wire is typically taken from coils or the protection packs depending upon the application. Okay, in this case, we have first of all we selected the wire with a diameter of 1.1 millimeter to 4.76 millimeter. After that, that wire fed up by a driven ruler. We have to fed the wire by a driven ruler. Then we have to flame it, we have to melt it by oxygen propane flame. Here this is a very important, that is oxygen flame is used in the melting the wire. Okay, oxygen propane flame is used as a source of flame for the melting of material. Then high pressurized air is passed. Why we used high pressurized air? Because this causes atomizes, and this project the melted wire material toward the target object so that it will bind to the surface. The wire is driven by air motor or a gearbox that forms a part of pistol mean where the flame of oxygen propane flame is produced. The air is the pressurized air is passed so that it can lead this melted material toward the target substance. Okay, then after that we have an arc spray. Arc, here we have two electrically charged wire are driven and guided that they converge at a point and form an arc. Here we have two different wires, that is which are both electrically charged, and they are driven or they are guided so that they converge, they join each other and form the shape of an arc. Okay. Then air nozzle atomizes the molten metal and project it forward toward the target. Sorry, I am repeating it again. Air nozzle atomizes the molten metal and project it toward the target. As we described in the previous slide, the function of air is here. The passing of air is very important in these processes because it leads the melted material toward the target so that it can bind there easily. Then here the wire are driven by air or electric motor and the gearbox. Mean these three things combine to drive the wire. Wire is taken from the source of wire is a different. Wire can typically be taken from portable MIG reels, coils, or the production packs depending upon the application requirement. As we have seen in these processes, that the main thing is the melting of the material, of the coating material, and then the air passes through, so that air leads the melted material toward the target, and after reaching the target it bind with the subject or the target easily, and when they bind they will act as a protective coating, and it prevents from the corrosion. And these methods involve, because these are the thermal methods, so this involves the heat. And in both the processes, whether it is wire flame or it is arc spray, in both the case we use the thermal technique. What is thermal technique? Because here in the case of wire flame, oxygen propane flame is used, and in the case of arc spray, we simply melted the material. And this shows that both these are thermal processes, and thermal processes are preferred because they increase the temperature of the target to very little extent, mean the increase of temperature of the target material is very less as compared to the galvanizing. So we preferred the thermal spraying over the galvanizing. Other than this, we have the one example that is used to protect or prevent the material from the corrosion, that is plastic impregnated ceramic coating, that provides wear resistance and a silk and non-stick surface, so that it can prevent the substance from the external environment. So the coating, the basic purpose of the coating is to prevent, or it act as a shield, and it protects the substance from the external environment. So due to the protection of the layer, the different compounds do not come in the contact with the air and the moisture and the different chemical substance present in the environment. Due to this reason, what is the reason? The reason is that the protective layer is separate, or it discontinues the reaction between, or this is not allowing the material and the and the chemical present in the external environment to react with each other. So by disconnecting, or by not allowing them to react with each other, the coating film will act as a protective layer for the target substance or for the desired material. And due to this application, or due to this phenomena, we can use the material for a long period of time without any damage. I hope so. This is very interesting for you to know about the thermal spraying and the protective coating methods for different material. If you have any question, you can ask me, or you can comment on the comment section. Thank you so much.